The overall goal of this protocol is to demonstrate the facile synthesis of worm-like micelles using visible light-mediated polymerization.
This method involves the preparation of polymeric nanoparticles, which can be used for a range of applications such as nanomedicine and cosmetics. The main advantage of this procedure is the production of worm-like nanoparticles using a two-step procedure.
The implication of this technique extends towards the field of drug delivery because in a number of studies, drug-loaded worm-like nanoparticles have shown to give increased cellular uptake.
To begin this procedure, add the appropriate reagents as indicated in the text protocol, a magnetic stir bar, and 50 milliliters of acetonitrile to a 100 milliliter round-bottom flask. Seal the flask with an appropriately sized rubber septum and steel wire. Then, cool the flask to less than 4 degrees Celsius in an ice water bath. Following this, deoxygenate the flask for 30 minutes by bubbling nitrogen directly into the reaction mixture through a 21-gauge needle, with a second 21-gauge needle acting as a vent. Place the flask in an oil bath at 70 degrees Celsius for 5.5 hours. Once the reaction is complete, quench the polymerization by immersing the flask directly in an ice water bath and exposing the contents to air. Next, remove the acetonitrile by agitation under a continuous stream of compressed air. Then, redissolve the crude mixture in approximately 40 milliliters.